we'll see a brief introduction. What is the use of these compounds, haloalkanes and haloarenes, in the day-to-day life, and how it is formed also. Many halogen containing organic compounds occurs in nature, halogen atoms, and some these are clinically useful. That means medically it is used. These classes of compounds find wide applications in the industry as well as in our day-to-day life. In industry, they are used as a solvent for relatively non-polar compounds and as starting material for the synthesis of wide range of organic compounds. Clinically important, this type of compounds also, because chlorine containing antibiotic chloramphenicol produced by microorganisms is very effective for the treatment of typhoid fever. Our body produces the iodine containing tyrosine, and it is used for the deficiency which causes a disease called the goiter. Synthetic halogen compounds, that is chloroquines, hydroxychloroquines. Chloroquines is used for the treatment of malaria. Nowadays, in this COVID pandemic, in the year 2021, it starts from the year 2020, it is continue. This year also 2021. So hydroxychloroquine is one of the use for the treatment of the COVID disease. Halothane is used as an anesthetic during surgery. Certain fully fluorinated compounds are being considered as potential blood substitute in surgery. So in this introduction, we find that how to find the halogen containing organic compounds in nature and how it is the clinically useful as well as it has wide use in the industry. Today's class is the haloalkanes and haloarenes, their structures. First, we will see the formation of alkyl halides or haloalkanes, in short it's called, and another aryl halides or haloarenes. The replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon by halogen atoms result in the formation of alkyl halides or aryl halides. That means when the replacement of hydrogen from the aliphatic hydrocarbons, then it is called the alkyl halides or haloalkane. When the replacement of hydrogen from these aromatic hydrocarbons, then it is by halogen atoms, then it is called the aryl halides. So for aliphatics, we will give one example. Suppose C2H6. This is the ethane we know. So one hydrogen will replace. That means Cl will add here and then one hydrogen atom will be removed by introduce one Cl atom. It is just the formation in the structure, how it is formed, the haloalkanes from the aliphatic hydrocarbons. Then it will be C2H5Cl. So now we understood that from the aliphatic hydrocarbon, by the replacement of this hydrogen atom or atoms, more than one atom we can also replace by the halogen atoms or atoms. Here we consider the chlorine atoms. Then it will form the haloethane or ethyl chloride. And haloalkanes contain the halogen atoms attached to the sp3 hybridized carbon atom, because these carbon atoms is the sp3 hybridized. We'll give the next example, then it will be very clear to you. Whereas the haloarenes containing halogen atoms attached to the sp2 hybridized carbon. That means if halogens, suppose you consider this benzene ring attached to is the chlorine atom, then this carbon atom is the sp2 hybridized. So here that means the halogen atom attached to the sp2, this sp2 hybridized carbon. Because you see that here one double bond also there. So if double bond is there, that means sp2 hybridized. But for haloalkanes, which comes from the aliphatic hydrocarbon is the sp3 hybridized, saturated, obviously saturated aliphatic hydrocarbons. Now classification on the basis of number of halogen atoms. That means it is possible one halogen atom is attached, two halogen atoms, three halogen atoms, and on that basis we can classify the haloalkanes and haloarenes. So if one halogen atom is attached, then it is mono. If two halogen atoms are added, then di, and more than two, that means then it is tri, tetra, etc. And it is called the polyhalogens. It is written there. You can find it. So now example. See in the first case, whatever we already discussed now, C2H5X. X is the halogen atom. Then it is called the monohaloalkane. But alkane, it comes from the alkane. In case it is the ethane. So it is usually called monohaloethane, and in general term monohaloalkane. If two hydrogen is added, then it is called the dihaloalkane. If three halogen atoms is attached, then it is the trihaloalkanes. So now we understood the classification of haloalkanes on the basis of the number of the halogen atoms. Now for haloarenes, if one halogen atom dielectrically attached to the benzene ring, this is called the monohaloarenes. That means it is the chlorobenzene in this case, but in general term is monohaloarenes. If two halogen is attached in the benzene ring directly, then it is called the dihaloarenes. I use the term directly attached to the ring. That you have to remember. And for trihaloarene, 3 halogen atoms directly attached to the benzene ring. Then it's called trihaloarenes. Containing the sp3-CX bond, where X, that means halogen, denotes for the fluorine, chlorine, bromine, iodine atoms. Monohalo compounds may further be classified according to the hybridization of carbon atoms in which the halogen is bonded. Classification of these compounds. How to classify these compounds on the basis of the hybridizations? So, alkyl halides or haloalkanes, it will have the R single bond X. Another one is the allylic halides. We'll go for structure just now. And another one is the benzylic halides. That means on the basis of the hybridization, we'll classify these haloalkanes, monohaloalkanes, as the alkyl halides or haloalkanes, allylic halides and benzylic halides. So what is these 3 types of compounds? First we'll go with the alkyl halides or haloalkanes. In alkyl halides, the halogen atom is bonded to an alkyl group whose general term we usually denote capital R. They form an homologous series represented by the CnH2n+1X. So this is the criteria and this is the structures. This is the structures for the alkyl halides. They are further classified as so this carbon, with which the halogen atom is attached. So on that basis, we can classify it as primary, secondary, or tertiary, according to the nature of the carbon to which the halogen is attached. If halogen is attached to a primary carbon atom, is an alkyl halides, then the alkyl halide is called the primary alkyl halides or 1 degree alkyl halides. The next we'll go for the examples. Similarly, if the halogen is attached to the secondary or tertiary carbon atoms, then of alkyl halides, then it is called secondary alkyl halides or 2 degree and tertiary alkyl halides or 3 degree respectively. Very simple. So we'll go for now structure of the primary, secondary or tertiary carbon to which the halogen is attached. So in this figure, you can see for primary, this carbon atom attached with the 1 halogen atoms, and here only 1 R group is there. It is written there R prime to distinguish the another from the another R groups. So this is called, when the carbon attached with the only 1 R groups, then it is called the primary haloalkanes or alkyl halides. If this carbon, which one attached with the halogen atoms, this carbon attached with the 2 R groups, then this carbon is the secondary carbon. So it is called secondary haloalkanes. In this case, every case you see that 1 halogen atom is attached. That means monohaloalkanes. For the tertiary, similarly, you see the 3 R groups is attached, R prime, R double prime, R triple prime, and only one halogen atoms. In this case, it is called the tertiary monohaloalkanes or monohalo. Now we will go for the allylic halides. What is this? These are the compounds in which the halogen atoms is bonded to an sp3 hybridized carbon which is adjacent to the carbon-carbon double bond. That is the to a allylic carbon. That means with allylic carbon, one sp3 hybridized carbon is attached and with which the one halogen atom is attached. In this case, it is the allylic halides. Example. Here you can see this CH2, that means this C is attached with the halogen atoms. And this carbon, again it is attached with this allylic carbon. This is the allylic carbon. That means having the double bond. Here also you can see it is one closed ring is there which is attached with the halogen atoms. So halogen atoms attached with this carbon, which one is again attached with the one allylic carbon. That means this is the allylic carbon. So this type of compounds is called the allylic halides. Now benzylic halides. These are the compounds in which the halogen atoms is bonded to a sp3 hybridized carbon and which again attached to an aromatic ring. Example, you see these halogen atoms attached with this carbon and this carbon atom is again attached with a benzene ring or aromatic rings. In same way, you can see that this carbon is attached with the halogen atoms and this carbon again attached with a benzene ring or aromatic rings. Now we will go for the compounds containing sp2 C single bond, X bond. X is halogen atoms. So this class includes vinylic halides and aryl halides. Now vinylic halides. These are the compounds in which the halogen atom is bonded to a sp2 hybridized carbon atom of a carbon-carbon double bond. We'll get one example. Whatever we told here that halogen atoms is bonded with the sp2 hybridized carbon. This is the carbon. So this carbon attached with the halogen atoms and this carbon has the double bond also. So that means it is sp2 hybridized carbon atom. From our previous knowledge of organic chemistry, we know. And for the second case also you see that these halogen atoms attached to this carbon is attached, has the double bond. So it is also sp2 hybridized. Now aryl halides. These are the compounds in which the halogen atoms is directly bonded to the sp2 hybridized carbon atom of an aromatic ring. That means in aromatic ring, whatever carbon is there, with that carbon, this halogen atom directly will attach. What is the example? Example, you can see that this halogen atom directly attached with this carbon, the aromatic ring. And this carbon also sp2 hybridized because adjacent double bond is there. This carbon has double bond also. So this is the sp2 hybridized also. And in this case also, same way, this carbon is sp2 hybridized. And it is directly bonded with the halogen atoms. And this type of compound is called the aryl halides.